Hey there, welcome to this video. We are going to talk today about coterminal angles, and these are just angles that end in the same location. So believe it or not, when you're in a unit circle, you can go around and around and around, and angles will end in the same spot. Now, how many times you go around, it makes it a different angle, and they end up being called coterminal angles. So let's go ahead, let's talk about what coterminal angles are and look at some problem applications. Okay, so here's the definition of a coterminal angle. A coterminal angle, or coterminal angles, are angles that share the same terminal side, right? Just where they end. And here's a visual example. I have the angle measure 257. So it goes around and it ends here, right? So that is the same angle as if I went in the negative direction, 103 degrees, right? Because they end in the same exact location. They share a terminal side. So that makes them coterminal. So since any number of revolutions for an angle of rotation are allowed, given an angle theta, there are infinite number of angles coterminal with theta. The angles that are coterminal with theta are written as a form theta plus 360k degrees, or 0 plus 2 pi k degrees, where k is any integer. And if you think about this, I mean, this totally makes sense. I have an angle theta. Now, it can be in degrees, right? Or it can be in radians, okay? Now, if I am in degrees, right, we know that there's 360 degrees in a rotation, right, in a circle. So if I multiply that by k, where k is any integer, like literally anything from negative infinity to positive infinity, right, I can get any number of different integers, or different angles, okay? And if it's radians, I'm going to add 2 pi, right? So this totally makes sense. 360 degrees around once, and if I'm talking radians, it's 2 pi. Okay, so here's kind of a task. We're given some problems that say, write an expression that represents all angles coterminal with any given angle. So my angle here, 210 degrees, it is in degrees. Okay, so what I'm going to do is I'm going to add 360k degrees. So all of my angles, right, are that. Okay, and I want to kind of specify this, right, where we say k is any integer. So I cover all my cases. Okay, the next example, notice this is in radians. I have 5 pi over 4. Okay, so if I want to represent the infinite possibilities of coterminal angles with this angle, 5 pi over 4, okay, and I'm going to add 2 pi k, again, where k is any integer. And if you're wondering about what about the negative cases, well, k can also be negative, so that accounts for those negative revolutions if I go in the negative direction. All right, so fairly straightforward. Here is some practice problems. Please go ahead. I want you to just write those expressions that represent all angles coterminal with these angles. All right, hopefully you have paused the video and tried these. Here are your solutions. Remember the degrees, right? So if I have 300 degrees, I have to add 360 degrees. And if I have 3 pi halves, then I have to add 2 pi, because we're talking radians. So those just kind of subtle differences. All right, now what they want us to do is they want us to find all angles coterminal with the given angle for k values of -1, 1, and 2. So what I'm going to do here is I'm going to write my general expression. Okay, so this is 225 degrees plus 360k degrees. Okay, so that's my expression. But now what I want to go ahead and do is I want to specifically identify, okay, what happens if k is -1? All right, and what I'll do is I'll take 225 plus 360, and I'm just going to drop in -1. So we end up subtracting, right, 360 degrees, and this gives us -135 degrees. Now I'm going to do the same thing. Okay, they say, what if k is equal to 1? So I have 225 plus 360. okay, where k is 1. So, I mean, that doesn't change the 360 at all. I'm just adding a revolution, and we get 585 degrees. Very, very straightforward, right? Okay, what if k is 2? Well, same story. I'm going to take 225 degrees, and I'm going to add this time 360 times 2 gives us our 720, which is 945 degrees. Okay. Now, how do we do this with radians? Well, I'm going to, again, take my pi over 3 plus 2 pi k. So there is my kind of formula, and I'm going to do the same thing. So I have pi over 3, okay, plus 2 pi times negative 1. So I end up subtracting pi. So I have pi thirds, okay, minus. Now, in order to subtract fractions, you need a common denominator, right? So this is going to be minus 6 pi over 3, and we get negative 5 pi over 3. All right. Okay, what if k is 1? Okay, this is simple. So I have pi thirds plus 2 pi times 1, which is just 2 pi. Okay, and converted to a fraction, that would be plus 6 pi over 3, which gives us 7 pi thirds. They're coterminal. They end in the same spot. Okay, next one. What if my k value now is 2? Okay, so that's 4 pi I'm adding, and if I write that as a fraction in thirds, we get 12 pi. So we get 13 pi over 3. There it is, right? Okay, so here are some practice problems. Please go ahead and pause the video. I want you to try these. All right, hopefully you have tried these. Here is the solution to these problems. Okay, and what we're gonna do next is now we're gonna specifically talk about the first revolution, and it's important that you realize that the first revolution for degrees, right? I'm talking about a positive revolution. Okay, and if I draw my unit circle here, I go around, it goes from 0 to 360. So you want theta, right, to be between 0 and 360 degrees. Okay, and if we're talking radians, we want theta to be between 0 and 2 pi. Okay, so that's kind of like what we're going to do here. So here it says find the angle in the first revolution that is coterminal with the given angle. So again, I want this angle to be between 0 and 2 pi. Okay, so notice I'm dealing with a pi half angle, so I want to adjust this. So this is going to be between 4 pi over 2. So notice how 5 pi over 2 is not. So all I do, right, is I'm going to take 5 pi over 2, and I'm going to subtract 2 pi. Right, I'm taking away a revolution, which is 5 pi over 2 minus 4 pi halves, okay, which is equal to pi over 2. So there you have it. Okay, now I'm going to go ahead, I'm going to do the same thing for 5 pi over 3. Again, you want it to be between 0 and 2 pi. So if I'm thinking about this angle, theta, I want this to be between 0 and 6 pi over 3, right? That's 2 pi. Okay, so notice I'm going to take negative 5 pi over 3, and this time I'm not going to subtract, but I'm going to add to put it in the first revolution, okay? So, and we always do this. I'm just going to either add a revolution, which is 2 pi, or I'm going to subtract a revolution. In this case, I'm going to add 2 pi, which we know that is 6 pi over 3. So this is pi thirds. All right. Okay, next one. Now, again, I have 21 pi over 4, so I want my theta to be between 0 and 2 pi, which in this case is going to be 8 pi over 4, right? I just did that conversion. And it's also nice when you do that conversion, you kind of know, like, okay, what you want your revolution to be in. You can also just kind of subtract by that. So I have 21 pi over 4, subtract 8 pi over 4, and what we get is 13 pi over 4. Now, is that within 0 to 8 pi over 4? No, it's not. So I just have to go ahead and take away another revolution, right? So we get 5 pi over 4, and there's your answer. Cake. Easy. Okay. Now, can I go ahead and do the same thing with degrees? I think it's easier with degrees. You want it to be between 0 and 360, so I don't even think I need to show this for you, but for the sake of continuity, right? Between 0 and 360. So what I'm going to do is I'm going to take negative 580, and I'm going to add 360. Okay, so I do this, and we get negative 220. So I'm still out of the first revolution, so I need to add 360. Okay, and I do this, and we get a positive 140. Okay, that's in the first revolution. All right, 600 degrees. I think you guys kind of get it by now. I want to be between 0 and 360, so I'm going to subtract 360. Okay, that gives me 240. And hey, that's in the first revolution. Simple. All right, here are some practice problems. I want you to go ahead, pause the video. Please try these. Okay, hopefully you paused. Here's the solution. All right, and the next one, please pause the video. I want you to try this one. Okay, and hopefully you tried. Here is the solution. All right, next example. Here's the last kind of topic. They want us to draw these angles in standard position. So again, kind of what's helpful is, like, I have no clue where 480 is, but if I kind of like break this down into, like, what is it gonna be in the first revolution? So kind of doing like what we just did. If I subtract 360, right, that is 120 degrees. So I know that this angle, right, I have to go around once. So here's 360 degrees, and then I have to keep going 120. So there's 90 plus another 30. So right here, there is my 480 degree angle. Okay, so pretty simple. All right, it gets a little more trickier with radians, because now I have negative 29 pi over 6. So sheesh. Like, what is this? Let me see. Okay, so you got to think about what is 2 pi in the radius that you're dealing with, right? So if I have a denominator of 6, this is 12 pi over 6. So I know it's a negative 12 pi over 6, right? That's one revolution. Okay, so notice I'm going negative, so I gotta go counterclockwise. So there's negative 12 pi over 6. All right, now I'm gonna go ahead. I need to go another 12 pi over 6. Okay, that's 24. If you're adding the numerators, right, that's 24 pi over 6. So let me go ahead and go around. Woo, going around again. Okay, there's 24. I'm still not there. I need to go another 5 pi over 6. And notice, right, 5 pi over 6, that's just before right here. This would be 6 pi over 6, right? Because that's pi. So I'm going to go back a pi third, right? Which takes us to right there. Okay, and that is negative 29 pi over 6. All right. Okay, here's a practice problem. Please go ahead, draw this angle in standard position. Again, when you're trying to figure out where it is, convert your angles to that denominator. So 2 pi is going to be 6 pi over 3. All right, hopefully you tried it. Here's the solution. Okay, and that is it. That is it for coterminal angles. Hey, remember, coterminal angles are angles that end in the same location. You can have angles that go in the negative direction. You can have angles that go around multiple times called revolutions, okay? And they're coterminal if they end in the same spot. And they have the same coordinate values. We'll talk about that next lesson. Peace.